Hello, welcome to the screencast recording for devops milestone 3, the team consisting of Rahul, Swagat, and Sharath. So, in order to set up our infrastructure, we have used AWS and Docker. Let's go into details. So, trigger remote and remote deployment. So this is our infrastructure setup where we have used three EC2 instances. In one instance, we are running the Redis server, and in the other two instances, we are hosting our application as a Docker container. The two instances are a part of an autoscale group, and the autoscale group is connected to an elastic load balancer. All this has been set up using the AWS CLI, and we'll go into the details now. So also the application is packaged as Docker container with Nginx that is running on port 80 and the application server running on port 8080. So let's look at how we are building the environment. So in order to set up the EC2 instances and the Redis server, we have written Ansible playbooks. This is in the install auto folder. So here we can see the Redis YAML file, which will run using Ansible playbook to install and set up Redis. And we also have the node script that we use to deploy um, the EC2 instances here. So once the EC2 instances have been set up, we use the AWS CLI to configure the load balancer. We can quickly check the load balancer config. So this is the autoscale group that has been set up with these two instances. So the name of the autoscale group is devops auto, and we have two instances as a part of it. And this is then connected to an elastic load balancer. Right? So this is essentially our infrastructure that is set up. Now let's trigger a build commit and see what happens. Uh, so, so what I'm doing is creating a file here. So I'm adding the file and committing it. Okay. So when we do a commit, we have this triggers a post commit hook. You can see the post commit hook here. So in the post commit hook, what we're doing is first building the application using maven install. So we're running the application using maven install. In maven install, we have test cases defined to check if the compiling of the application is going correctly. If there is any issue with maven install, it will not go through. Once once the compilation and install is complete, and the build is successful, then it will build a Docker container with that particular build version. So we build the Docker, and then we check if there are any errors, and if there are no errors, then we push it to the Docker hub. So that's our essentially our architecture, wherein we build the app and then push it to the Docker hub. So as you can see, we can see the build is going on right now. Let's wait for the build to complete and then we'll continue. As you can see, the Maven package build was successful. So once a build is successful, then it builds the container. So let's have a look at the Docker container, how it's being built. So this is the Docker file. So in the Docker file, we are first using our base Ubuntu image, installing the necessary packages, and then setting up Nginx. In Nginx, we're setting up the proxy configuration to redirect all traffic to port 8080, where the application is hosted. So once the command to initialize startup.sh, when we run startup.sh, we essentially trigger nginx, and and then and then we do maven ninja run, which will start the application. So this is the web server and this is the application server. So this is so now the Docker containers are being built, and it's pushing to the container was successfully built, and now we're pushing, since the build is successful, we're pushing it to the Docker repo. Once the post commit hook runs and we have the container set up, it is pushed to the Docker hub. Now our setup is such that we have two remote repositories set up on the two EC2 instances. The production repository is on this IP address on this instance, and the staging repository is on this one, on this IP address, right? So so now so what now once this is done, what we can do is we can instantiate the push now, because the commit is successful. So we do a git push, we push it to the production repo. I'm pushing master, right? So when we do a push, so now we can so once we have the git remote set up, we're going to push it to the production environment now. So git push. Okay, so here we triggered a push. As you can see, we are seeing the logs now from the remote side of what's happening. So on the remote end, we have a post receive hook that has been configured. Let's log on to the AWS instance. These are the AWS instances that we have running. This is the product. So the production server IP address is this. Let's log on to the production server where we triggered the push. So ls SSH Ubuntu at this. Okay, so let's log on to the AWS. So this is the AWS instance that we have. We have created the production git repo here. So once we log on to the production git repo, and we can see the hooks. So we have a post receive hook here. What it's essentially doing is it is pulling it from the public repo to which we had pushed the image. If the pull, after the pull is complete, it is going to stop the current container, and then it is going to start the new container that we just pulled, right? So this is completely automating the build setup on our remote EC2 instances on a successful commit and a push to the git repo. We can see that this is we can see that the app is running on the repo now. Let's check the AWS instance. This is the public IP address. So we log into the public IP address now. The app is running on port 80. So this is, so here we can see the app is now running, and we can see this is the application that we have set up. So since we're using AWS for monitoring our infrastructure, we have AWS provides a very good dashboard for monitoring the metrics and alerts. So as you can see on our EC2 dashboard, we have the production and staging servers, and we have set up monitoring using CloudWatch alarms. So these are all the stats that you can see here, network, and so primarily we are monitoring network and CPU utilization. So let's look at the production server here. On the production server, we have set up an alarm for CPU utilization in order to send out an email to this particular user. So whenever the CPU utilization goes above 1%. So this is the alarm that we set up for CPU, and as you can see, we've received alarms from that particular instance from AWS when the alarm when the threshold has exceeded the threshold that we set as 1%. Similarly, we have also set up alarms on the staging server, and here we have set up alarms for high network output and um, for failed checks.
Thing that I'm going to show is the auto scaling feature of our application. So in order to implement the auto scaling feature, what we have used is the AWS auto scaling feature. So basically what we have done here is using AWS CLI, we created an AWS autoscale group, and then we created a separate launch configuration. So as you can see here, our launch configuration is called as DevOps EC2. I'm showing it using the AWS console here, and currently we have 2 instances running, and the minimum number of instances that should run in the autoscale group is 2, and the maximum should be 5. And also so basically what the autoscale group here will do is that it is monitoring various group metrics collection. So we have implemented various group metrics, so it looks for that metrics, it continuously monitors that, and if it finds that certain metrics are being are below the threshold values, then it sends us an alarm. So as you can see here, these are some of the alarms that we received. We are using CloudWatch alarms to send all our alarms. So this is one of the alarms that we received for CPU utilization, which is one of our scaling policy here. So in order to show you what a scaling policy is, so basically here what we're doing is we are setting a scaling policy which says what the autoscale group needs to do when a certain condition is met. So in our case, we have said that whenever the CPU utilization, average CPU utilization of all the instances grows beyond 50% and for a period of 60 seconds, we add the we tell it to add one more instance into our into the autoscale group. So currently there are 2 instances running, and say the load grows beyond 50%, then it will spin up one more instance and add it to the autoscale group. So as you can see, these are the instances that are currently running, and we have set the notification. So we have set we have told it what it should do. So whenever a new instance is launched or terminated, or fail to launch or fail to terminate, it will send us an alarm, as I already showed you in our email. So those were the alarms that we got after stress testing the instances. So this is how we implemented autoscale groups. So now I am going to show you how we implemented feature flags in our application. So in order to implement feature flags, we have used a Redis server. So the Redis server will be running in a separate AWS instance. We have hosted the server remotely, and we have deployed it using Ansible. So once we have the Redis server up and running, what we do is we all the instances where we deploy our app connects to the Redis server, and then it establishes a connection. So in order to make our app work with the Redis server, the initial app that we had did not have any Redis client in it. So we had to modify the application code so that it automatically initializes a Redis client, and then it connects to it. Also, for any new feature, we added a separate key in our Redis server which we call as flag. So currently this is the Redis server that we are running. So you can see that if I do a get flag, it gives me the value 0. So how we implemented it was this. So whenever the flag value is set to 0, any new feature that we wanted to implement will not get deployed. So we have put in checks in our application which prevents any new feature to be deployed if the flag is 0. Only when we set the flag to 1, the new features can be are deployed and can be seen. So now we have already deployed our application, and we have now the flag value is 0. So let's go here and test and see what our application look like. So this is our application, and we implemented a feature, say, called as new feature. So new feature is a new implementation, and we wanted to see if we are able to view this, if this feature is enabled as of now. So as you can see, when I typed in new feature, it redirected me to the initial page. So this is a desired action because we have not set the flag value to 0. So coming back to our Redis CLI, so let's set the flag value to 1. So now you see that this is the remote, in the remote instance we have set the flag value to 1, and then let us come here and try to access the new feature page again. Okay, so now now you can see that we are able to view the new feature page here, and it is not redirecting us to our previous, to the initial home page. So as can be seen, now the flag value is 1, and again if we set the flag value to 0, you can come here and you can test it again. We run new feature again, and there you go, we are being redirected to our initial home page. So this is how we implemented the feature flags in our application.